This is the homework review video for 12-4 day 1. So you're going to get out pens so that you make improvements the same as we would do in class. You're going to pause the video to try a setup maybe that you see yourself. If your setup is the same, then you get a calculator and you check to see where the calculation challenge is coming. Ask a neighbor and move the video ahead to check things if you don't need a particular problem. So this was your assignment, the 1 to 7 odds and 13, just a small number of problems to get your feet wet with law of cosines. So starting with number 1, remember law of cosines works two different ways, but if we're looking for a missing side length, the reason we would use it is we have the other two sides and the angle in between. We have the SAS condition. So when we start to set this one up for number 1, I know that my law of cosines is going to have to begin and end with things across from each other. So we'll have to use cosine of 49, and we have to have w squared on the other end of law of cosines because they always are opposite one another. So for that, that's going to look like what I've got. And then that one, everything is on the right-hand side ready to calculate. And yes, that's a lot to put in your calculator, and make sure that you can calculate accurately. So take it slowly, and then take its square root so that you can get to n to the nearest centimeter to 32 centimeters. In number 3, again, you've got the 82-degree angle and x across from each other. So since this is another law of cosines setup, since it's SAS that we're given information, I do know my law of cosines is going to begin at x and end with cosine of 82. So my setup, again, pause the video where you need to. Again, that one was all ready to calculate all in one. There was no algebra to be done to get x isolated, and I'm rounding to the nearest centimeter. Number 5 was another law of cosines because law of cosines is also good for side, side, side in helping us locate a missing angle. So whatever the missing angle is that we're interested in, we need to have across from it be the beginning and ending of our law of cosines setup. So we're going to start with 390 squared equals, and we're going to end with cosine of b. So it's going to look like that. Here's where you have to be careful and show multiple steps of how that algebra is going to isolate the cosine of b ratio that you're going to come up with. And that can look a few different ways. I prefer to subtract all my squared terms first. What you have to be very careful of is this final expression is attached to cosine b and can only come off by division. So eventually you can calculate this number, which is the negative 266,000 on mine. And then this number is what you have to, so you have to divide by this negative 266,000 value to get a ratio worth cosine b. Now that we know the ratio of cosine b, it's time to use a little inverse cosine to get that angle. So again, watch your setups. Finally, in 7, the two 24-centimeter radii, a picture would help you a lot to envision that triangle so that you can see law of sines will not work here. You have the law of cosine setup. And again, with the idea of acrossness, the angle and the side length across from each other have to begin and end our law of cosine setup, which you can see. And this is another one of the straightforward setups. L is already isolated and ready to be solved for, and therefore you can go ahead and get that final length for your cosine value. The last one, number 13, with the painting company and the safety rule. You do know what Regina did, where she put her ladder. And then you do know what they suggested or what they require as their minimum and maximum angles that the ladder needs to make with the ground. A minimum angle of 55, and they'd like maximum angles of 75. So you're making a comparison of 3 different things. This is all right triangle trig. You could use law of sines or cosines if you can apply them, but you really don't need to. This is basic right triangle trig since the ladder is against something that's at a perpendicular to the ground. So for Regina, I would start with Regina, realizing she has a 6-foot opposite leg that she is using as her distance away from the base of the wall. And she has a 25-foot ladder that's not going to change size anytime soon. So she has a cosine ratio. And if you calculate, you can see my setup and see good notation with your inverse. And so Regina's is at a 76.11 degree angle. So technically, according to their rules, it's not placed safely. Her ladder is actually too close to the wall because that angle has gotten too big. So then to see what her parameters are, the minimum angle set up, again, my ladder's not going to change. It's 25 feet. I know the minimum angle is 55 degrees. And if I calculate with that, I'm going to get that the distance from the base of the ladder to the base of the building needs to be about 14.34 feet. Or if I use the maximum allowed angle, again, I'll set up a cosine expression to get that maximum angle that's allowed. Then I can make some conclusions about how far away from the wall that ladder can actually be to be within their safety parameters.